This video will examine the coordinate plane, which is a great tool to use as we go forward and start to look at functions, a really essential topic, and I know I keep saying that about every topic in Unit 1, but it's building on all those blocks that you will be using in this year and going forward into Analysis 2. We have a horizontal axis called the x-axis, a vertical axis, and that's called the y-axis, and they intersect at a point called the origin, and that has the coordinates 0, 0. First coordinate represents the x-coordinate, and the second, the y-coordinate. So the example point that we have right here, AB, the x value is A, and the y value is B. If you notice this point P, it's in the upper right quadrant called quadrant 1. In that quadrant, both coordinates are positive numbers. The second quadrant right here has negative x values, but positive y values. The third quadrant down here, both coordinate points, x and y, are negative. And the fourth, the points are positive for the x and negative for the y. And you will definitely use these quadrants, especially when we get into doing trig later in the year. So now let's look at two formulas, the distance and midpoint formulas. And you may have seen these in a previous math class. So let's look at a little proof of these formulas. Here I'm going to mark point A, and its coordinates are going to be called x sub 1 and y sub 1. Those little ones are called indexes, and they're going to differentiate between points, whereas I'm going to choose another point, let's say up here, and we're going to call this point x2, comma y2. So here is point A, and here is point B. And our goal is to find the distance between point A and point B, and we can't just count the boxes because notice we're going to have only parts of certain boxes and it becomes difficult. So instead, we are going to create a triangle, and it's going to be based off something called the Pythagorean theorem. And this theorem says that the sum of the legs, and we're going to call those a squared and b squared, well, that's equal to the hypotenuse squared. And the hypotenuse is the longest side of your triangle. So let's go ahead and build our triangle. And then we're going to find the lengths of all the sides. So the bottom side right here, if we look at that leg, that's all across the x values going from x1 to over here at x2. So its length will be x2 minus x1. And if we look at the other side, the vertical side, what's the distance here? Well, notice we're going from y to y, or from y2 to y1, so it's y2 minus y1. So we have values for our legs, and we're going to substitute that into our good old Pythagorean theorem. And we can label our sides A, B, and that hypotenuse we're going to call C. So if we plug these into the formula, we're going to get a squared, and that's going to be x2 minus x1 all squared, plus b squared, which b squared is y2 minus y1 all squared, and that's going to be equal to c squared. And our goal is to find the hypotenuse, or just c by itself, so we're going to square root both sides. That's going to give us the square root of x2 minus x1 all squared plus y2 minus y1 all squared, and that's equal to c. And that is our distance formula. Right? This is our distance formula. And it really is just the Pythagorean theorem, a squared plus b squared equals c squared, just on the coordinate plane. If you're using Equatio, all you really need to do is type in DIS, and it probably will pop up this formula for you, so no need to memorize it. So let's put this into practice, right? Which of the points P, Q is closer to the point A, which is 5, 3? Let's first find the distance between P and A. And notice I wrote that with a little D out front. So it helps me to go ahead and label our points so we know what's going to be x1 and x2, y1 and y2. I'm going to call my P point my x1 and my y1, and my A point x2, my x2, y2. Now we're just going to plug that straight into our formula. Is x2 minus x1 all squared, and then y2 minus y1, and notice that's minus a negative 2 all squared. And if we simplify, we'll get 4 squared plus 3 minus a negative 2 is 5 squared, and this will give us 16 plus 25, and that's just the square root of 41 for our distance between P and A. So now let's find the distance between Q and A. So our A, our x2, y2 will stay the same, but I'm going to erase above my P and change Q to become x1 and y1. And if we fill in the formula, we'll get 5 minus 8 all squared plus 3 minus 9 all squared under our square root, and ultimately that gives us square root of 45. And now here, don't be concerned about simplifying your square roots, because our overall goal was to find what? Which of the points is closer to A, and closer to A would mean a shorter distance, and which is smaller, square root of 41 or square root of 45. Yep, you guessed it, it's square root of 41, so that means that point P is closer to A. The other formula we want to look at is the midpoint formula, and that formula as well is an equatio, right? The minute you start typing midpoint, it'll pop up to make it easier when using it. Really, to find the midpoint, we're going to take the average of the 2 points, right? We're going to take x1 plus x2, divide by 2, and then comma, y1 plus y2, and divide by 2. So in our example here, the midpoint of P is going to be, take our x's, a 1 and an 8, so 1 plus 8 divided by 2, then take your y's, negative 2 plus 9 divided by 2. And it doesn't matter which order you go in, as long as you remember the x's go together, and then the y's go together, and you're averaging them. We finish this out, we're going to get 8 plus 1 is 9 over 2, and negative 2 plus 9 is 7 over 2, and there's our midpoint, 9 halves, comma, 7 halves. And that's it for looking at our two formulas, distance formula and midpoint formula, as we start to look at the coordinate plane.